Hello, everyone. Let's look at this series here. We are testing the series for its whether it's convergent or divergent. And so, because we see that an exponent is involving n here, and n is changing, right? So n equals 1 and 2 and 3 and 4. So if you're writing out the terms, then you are going to have to deal with the base with the n in there, and also in the exponent there is the n in there. So in this case, we are going to use the root test because that will actually get rid of this n, and then that will make us um, take the limit a lot easier. Okay, so let's try this. So first, we are going to just let a sub n be just this whole thing, right? So that's the usual way of starting it. So we are going to let a sub n be just this whole expression. So that's 4n plus 5. And then we have what? We have 3n plus 2. Okay, and then we get an n here. And so see what's going on here. We are going to get what? Let's just take let's just consider the nth root, right? So we are taking the nth root of this a sub n, the absolute value of this a sub n. So let's do that. So if we have a sub n here, and then we are taking its absolute value, so 2 bars around it, and then we are also going to take the nth root of this, and then guess what? What does it look like? It's going to look like this. We are going to have the 4n plus 5, right? It's the same expression in there. And then the 3n plus 2. And then we have the n power right here, and then we are taking the absolute value of this. And then we are taking the nth root of this expression here. Okay, so that looks too bad. Okay. Yeah, so let's look at this expression. And then now, because we are our n values are starting from 1, 2, 3, 4, they're all just whole numbers, right? Positive whole numbers. So we are going to get a positive quantity here and then raise to the n power, and n is, yeah, this is the base is positive, the exponent is positive, and all that is positive. So we do not really need the absolute value anymore. And so in this case, we are going to just get the nth root of all that stuff. So that's, again, that's just 4n plus 5. And then we are going to get the 3n plus 2, then to the n power. And then now if you simplify that, that will just give you what? That will just simply give you. This is 4n plus 5. And then what do we get here? We are going to get the 3n plus 2. Okay, so that's what we have there. Actually, I can just move this on the side. So let's just put that here. Okay, so now what do we need to do? We're going to take the limit. We're going to take the limit of this. So the limit as n approaches infinity, okay, of what? Of this, the nth root of the absolute value of a sub n. So that's what the root test is talking about, right? So now that's equal to what? That's equal to the limit of basically just this expression, because we did that simplifying here already. So we are going to get what? 4n plus 5, and then all over 3n plus 2. Okay, so we all know how to calculate this one. All we need to do is to just factor out the n. Right, so we factor out the n. Then we are going to get n times what? 4 plus 5 over n. Then same thing is happening in the denominator. So we have n, and then 3 plus 2 over n. And so you know that we can actually just cancel out the n there. And so if we are doing the canceling, then when n is approaching infinity, then those two fractions, right? Those two fractions, they are all approaching zero. So this fraction here is approaching zero, and this fraction here is approaching zero. So what is the answer here? We are going to get 4 over 3. And according to the root test, if this number is greater than 1, this limit, if it's greater than 1, is it greater than 1? Yes, it is, right? 4 over 3 is greater than 1, then by the root test, then what happens? Then the series diverges. So, so by the root test, the series, that's the whole series that we are writing down here. So 4n plus 5, and 3n plus 2 is divergent. Then our answer, just highlight the answer. Okay? Okay, so that's it for this problem. And you may say, when do we use the root test? It's when you see this kind of power here. There is a base. There is an expression with a base involving the n in there, and then in the exponent there is also an n in there. That's the whole thing is raised to the n power. Then we'll usually try the root test and see what happens. Okay, so if you find this video helpful, please subscribe to my channel and then give me some support. I will continue to make more math videos in the future. Thank you for watching. I will see you next time.